Hello, everyone. My name is Tamara, and I wish you welcome on behalf of myself and InterVenture. We are a Swiss company which specializes in building remote software development teams in our engineering hub in Belgrade. We are based on 2 locations, and we have more than 220 developers under our roof at the moment. One of our partners is Ricardo, which is one of the largest online marketplaces in Switzerland, and Ivan Nikolic is their senior backend engineer who will talk about graph databases today. When I asked Ivan to share something about himself, other than mentioning that he's a professional, he's 10 years professional experience, he said that his profession is also his hobby and that he enjoys spending time and learning new programming languages and technologies. So well done, Ivan. Welcome and thank you again for joining us. After his presentation, you will be able to ask questions using Q&A option at the bottom of your screen. And I hope you will all enjoy this webinar and learn something new that you can implement in your own projects. Thank you again. And Ivan, the floor is yours.
Thank you very much, Tamara. Let me just share a screen. And please just tell me if you see everything correctly.
You can raise hand.
You see it, right?
Yes, everyone is raising hands.
Okay, so thanks for the introduction. Hello, everyone, from myself, and welcome to InterVenture webinar. The topic of this one is actually graph databases and how we can use their power if we have data which has a high degree of relations. So bear with me. I will be explaining this concept in a moment. So, the agenda will be the following. The presentation will be around 15 minutes. We'll do an introduction, the comparison with relational databases. We'll show some use cases, and we'll tell you what we do in Ricardo with graph databases. And then later on, we'll have a bit more interesting part, which is a hands-on, where we are gonna build a small recommendation engine for a web shop. And later on, we leave time for Q&A. About myself, so as Tamara introduced me, I'm Ivan Nikolic. I'm a dog owner. I have around 10 years of experience in software development. I'm mostly backend engineer, and Java is my main language. I'm working in InterVenture for around 2 years, and we are building a largest Swiss online marketplace, which is called Ricardo CH. Let me open up this presentation by repeating the previous slide about me, but this time I will show it as a drawing. So this is me, and as I said, you already saw it. I have a dog, and here it is. And his name is Buddy, and Buddy and I are in a kind of a relation. And technically I own him, and I'm responsible for him. And did I tell you about InterVenture before? It's one of these great companies located in Belgrade, and I'm also related to it because I work in it. So here is a connection between me and InterVenture. And as almost every software engineer, I have my favorite programming language, which is Java. And I obviously speak Java. And this is a connection between us. But not only I speak Java, I also love Java. So there is one more relation between us. So yeah, this is again me in few icons. And this is exactly how the simplest graph looks like. So basically, a graph, a graph is just a set of entities which are kind of connected between themselves. On the other hand, the graph database is just a tool that should allow you to model, to store, and to query your data as a graph. Every graph database is actually an implementation based on mathematical graph theory. So in the end, it's just a pure math. And all better graph databases are expected to have all the features like traditional databases, like clustering, indexing, backups, replications, to be resilient, highly available, blah, blah, to support transactions. but I'm not gonna bother you too much with it. I'm gonna show you something different. So you would need to kind of transform this drawing that I showed you, which to something more more readable for a person who works with a graph database. So on the right-hand side, you can see the same diagram, but in a different notion. This is how we usually draw things for the graph databases. So modeling data as a graph is a bit different from how you would model it in a traditional database, because there are no tables, and you do not store your data as a grid. So I would like to explain you a few concepts that are most important in every graph database. So first and foremost, there are nodes. Nodes are the entities in the graph, and they are meant to store the data. So every entity that you would like to store in a graph database is actually a node, just a simple node. In a graph theory, in mathematics, a node is often called a vertex. So and if we compare the graph database to a traditional database or relational database, it's something like a record in a table. So on this slide, you can see 4 nodes: a person, a dog, a company, and a programming language. The second concept are relations. Again, in mathematics, they're called the edges. Relations are actually pointing from one node to another, and they are used to create a connection between 2 nodes. For example, a person owns a dog, or a person works at company. So these arrows here are actually the relations. Why arrows? Because every relation actually has a direction, meaning that it goes from one node to another. It has a start node and the end node, and the direction is really important. Analogy to a relation in a traditional database are joins. When you join, for example, multiple table, this is something similar to what you would do in a graph. What's going on? It's really important to say that relations are a first-class citizen in every graph database. So this is actually what makes the graph database so strong when it comes to highly connected data. And then a third concept are labels. Labels are something that can group similar nodes and relations together. For example, this person name or a dog or a company, just a label or a tag on the node or on the relation. As I said, they act like tags. They're here for easier lookup, and each node can have 0 or more more labels. But usually you would see nodes with one single label, as I described here. The last concept are the properties. This is they're actually key value pairs. They're stored inside each node, and they describe better the node. In this example, for example, a person has a name, a city where he lives, the age, and so on. The company has a name, identification number, sector, and so on. The schema is usually not fixed in a graph database, so you can basically put almost any key value pairs. So before I go actually through this slide, I would like to say that I'm not really advocating to use graph databases everywhere. I mean, they're really good for some scenarios, but they cannot and they should not completely replace traditional databases. But I would like to tell you about the use cases when you should consider using the graphs. So first question, why relational database cannot handle the relations well? When you have a model with a lot of relations, it becomes complex. I mean, you come to a point when you cannot really model or store data with so much complexity relationship-wise. When the number and level of relationship increases in a relational database, in a traditional database, your performance will degrade, the development will be slower, the scalability will be lower, it will be harder to maintain. The query complexity can literally explode, which I'm going to show you later. And also adding new types of data and relationship requires a schema redesign. So, and as I showed you, graph databases are usually schemaless. So there are some specific use cases where you would actually benefit from the graph database much better than from the traditional one. Here, I just wanted to give you a quick teaser about the query language that graph database uses. I took this picture from Neo4j site. This is one of the most famous graph databases. So it shows them on the left side. It shows them the query in a query language called Cypher. It was originally developed in Neo4j, but it's also used by some other graph databases. It's definitely not the only query language available for graphs, but it's certainly most popular one. So I will show you the language in more detail in the hands-on section, but here I just wanted to point out how simple it can be. So on the left-hand side, you can see the Cypher query, and the purpose of this query is, for example, within a big company, a manager wants to get all other managers that actually report to him, and they're up to 3 levels below in the hierarchy. And for example, a CEO wants to see management hierarchy below him, and for each of his reporters, he wants to get how many people they manage. This is just some kind of an example. On the left-hand side, it's a Cypher query. On the right-hand side, the SQL query. You can see that for example, in this specific case, it's so much easier to model with Cypher. You do not probably understand what it means, what the query means, but you can understand how it solves the complexity. And it's also important to say how cheap it is to traverse through relations. So this query on the left-hand side can be probably executed within a few milliseconds in a graph database because relations are a first-class citizen, while the SQL query on the right-hand side might take a lot of time to execute unless it's a super much indexed database. And also the right query tends to be much less scalable as the data grows in size. But to be honest, I haven't tried out these exact queries, but I can tell you for sure based on my previous experience. The most popular options for graph databases on the market, definitely Neo4j. If you want to check out something, definitely check out Neo4j first. The ONGDB is a fork of it. I will mention it later. And you will have in this presentation the reference to a few other bigger graph databases. When you would like to use the graph database, these are some of the most popular use cases. But as I said, whenever you have a lot of relations, and actually you're working more with the relations than the entities themselves, probably a graph database is a good option for you. So some examples are social networks, some real-time recommendations, which we're going to try to build something like this in a hands-on section. The fraud detection, when you try to model the network or some kind of other IT operations, when you want to handle the access management, when you want to do a graph-based search, and many other use cases. I would like to mention another use case, which is, I call it the Ricardo use case. As Tamara mentioned, so I'm working for Ricardo, and it is the biggest online marketplace in Switzerland. It's something like similar to Amazon, or if you come from Serbia, it's something similar to Kupujem Prodajem. We use graph database for article classification. It's not our main database. We have quite a few others, but in this database is quite a central point, meaning that it stores everything related to articles, categories where they belong to, the attributes, the product types, and their relations. And just to give you a heads up about this, on the size of our graph database, we handle 1.3 million unique active accounts we had last year. We have almost 2 million open articles at the moment. In our graph database, there are around 30 million nodes and relations. Our graph database receives between 1K and 2.5K requests every second. And yeah, we actually use the ONGDB, which is actually just a fork of a Neo4j database. And we run it in production for more than a year, and we're quite happy with it. So now we come to a second part of this webinar, which is a hands-on. And since I'm not really allowed to share details of the implementation in a Ricardo shop, we're going to build together an InterVenture shop, or at least the database for the InterVenture shop. So how is it going to look like? The InterVenture shop is a place where users, primarily the employees of InterVenture, can buy and sell products. Products are grouped into categories. Categories form a category tree. For example, sport car belongs to car belongs to vehicles. Vehicles can also contain some other subcategories and so on. So they form a tree. Users can make a public watch list of the products they're interested in. Users can follow each other if they find each other interesting. Users can follow categories that they find interesting. Users can endorse each other after a successful purchase. And we're going to build a recommendation engine in the database that helps users find products that they might be interested in. So if you want to follow along, or you want to check the stuff with me, you can scan this QR code, and it will lead you to the GitHub page where you can find all the code. Yep. So let's start. As I said, we are building an InterVenture shop. Here are some of our employees. They sell some stuff. For example, Alex sells some car. Dejan sells a bike. Dragana is selling a pair of shoes. A bike. Each of these products, a car, a bike, and a shoe, a pair of shoes, actually belong to some category. For example, bike belongs to category bikes. Car belongs to category cars, and this pair of nice shoes belongs to category shoes. As I said, there is also a concept of category tree, which means that we have, for example, an abstract category vehicles, and bikes and cars actually belong to this one. As I said, users can follow each other. For example, Miloš follows Dejan, and Robert follows Alex. Users can also follow the category. For example, Miloš follows the vehicles and Tamara follows shoes. Users can put stuff on their watch list. They're interested in them, but they are not going to buy them immediately. Users can purchase an item, and after a successful purchase, a buyer can endorse a seller, and also in the opposite direction. So if we now move this chart to GraphDB Notion, it would look something like this. So we would have these nodes, their properties, they're all labeled, and they have relations between them. So I will now start building this. But before we start this, I need just to show you some basics of the query language that we're going to use. So it's called Cypher. It's first developed in a Neo4j, but now a few other graph databases adopted it. I'm going to show you how the notions look like in Cypher. So, for example, if you wanna select the node, the first one, just the brackets is a node, any node, and then the second one is a node with a label. So it would select, for example, all the nodes with a label person. Or the third one is it has a label, it has a property, which is brand Adidas, and it also this p here is actually a variable that we give it inside the query. There is a relation notion, so you can see the two nodes p and c on the left and the right hand side, and between them, between the arrow, you can see the relation. This is something similar to what you would draw on the whiteboard exactly if you want to draw a graph. Then, if you want to select nodes and relation, you would do something. You would use a match keyword. So here I select a user u1, which is who is friend with user 2. If I want to create some node, I need to give it a label if I want and properties. So this will create a new user with the name Darth Vader. I can, within the query, I can set, for example, on a variable u, I can set a property, for example, age 25. I can delete a node. I can return the result. For example, I returned user 1 and user 2 that I selected here. And there are actually many more different notions and keywords and so on, but these are the most basic ones that we're going to need. So how we can spin up the Neo4j community server, also on this GitHub link, you can see, you'll find the Docker Compose file, and just by running Docker Compose up, you will be able to have a database running on the port 7487. So I already have it, so I'm not gonna do that now, but I'm gonna go to the database and we're gonna start creating some nodes. So let me just go back to, just a sec. Let me go back to this screen, yes. Sorry. Okay, so first of all, for example, I want to create my first user. So I will say, okay, create for me the user with the name Tamara. Okay, and one node is created. I can see it here on the right side. So there is now a node with the name Tamara, and it has a label user. I want to create another one. Create user name Letitia. Okay, and now there are already two users. So I can continue repeating this query. I will not do it for a long time. I will just copy paste the whole data set, but I would like to show you a few things. So for example, I want to create a user Milos and user Dejan, and I want to create immediately a relation between, I give it a variable m and for Dejan D, and I create immediately a relation between them. So Milos then follows Dejan. So if I now check for the users, I have Tamara, Letitia, who are here standalone, and Milos follows Dejan, and so on. So I would not, we do not have enough time, so I would not bore you with creating everything. So I'm just going to go to the GitHub repository, to the file sample database.cp, and I'm gonna copy paste everything into my console and just execute it to have all the data. Okay. And now we have many more things. So for example, these are all the users, these are all the products, all the categories, or if I want to see really everything, it looks like this. I added a bit more data than it was in the diagram. So a few more products just to have a recommendation engine more interesting. So if you want to check how these queries are done, just open GitHub and you will find the script here. But basically, it's similar to what I have showed you. Okay, so now we will try to build a recommendation engine. What is that? We will actually try to recommend some interesting articles to our users based on different criteria. For example, things that they watch, based on people they follow, categories they follow, based on what they purchased, and so on. This recommendation engine is going to be pretty simple, and I mean, this is really tough stuff to make. And in order to do that, you need way more context than we have in this database. But just try to imagine. I mean, this is the way to do it, but just with a more information and data. So the first thing, which will be the easiest one, is the watch list. So for example, we would like to show the users just a list of the things that they watch. It's not really a recommendation, but it's based on the data that we have. For example, Letitia watches this pair of shoes and a bike. So if we go back to our database console, I will close this. First, I will try to find user Letitia. Okay, I'm searching for a user with name. Let me just first check that I found it. Okay, she's here. And when I want to also return her stuff that she's following, I would just create a relation. I would try to find the relation, watches, and then which products is she watching. If I return this, oh, sorry, I need to return products as well. I'm getting here now her watch list. So this can be later on simplified. I can do it in a single statement. For example, this user, this node, is connected with a watches relation to a P node. And yeah, it's her watch list. Or if I'm just interested in products and not her itself, it's this. The second recommendation that I would like to build with you is, for example, on our web shop, you would get a section saying because you follow user and then X. For example, Robert follows Alex, and he would maybe like to see on his homepage because you follow user Alex, and then see the things that Alex sells and things that Alex watches, because the watch list is public, as I said. So how would we do this? So yeah, let's try again. Let's try with Tamara this time. I'm searching for her. Okay, here she is. And then I would like to find which users is she following. Okay, so Tamara is actually following Dragana, Alex, and Dejan. So you can see, okay, this endorsed relation is here automatically, but just take a look at this follows relation. Tamara follows Alex, Dragan, and Dejan, but I'm now interested in actually in their articles. So I'm gonna try to match this user. So match you with to see what they sell or what they actually watch, and its connection to products. And now I'm actually interested just to see the products and nothing else, or maybe U and P, the users that she follows and the products. So yeah, as you can see, she follows Dejan, and here are his products, the products that he watches or sells, Alex and the products he watches and sells, and Dragana. These are actually the users that Tamara follows. And she would get probably 3 sections on her page, one for each user that she follows. Okay, the third recommendation is similar to a previous one, but slightly different. You would get a section based on all categories you follow. So what's actually the trick there? For example, Milos follows the vehicles, but we would like to see all the articles that are in the vehicles, plus in all the subcategories. And in this example, there is just one level of subcategories. For example, there are just vehicles and then cars, but maybe inside cars there is a sports car and there is maybe even another level. So this can really form a tree below, and we need to check everything. And this is actually where relational databases are great. So how could we do this? Let's try now for a search for Robert. Okay, and first we need to check which categories he's following. And we also, whoops, sorry, we also want to check the subcategories. So let me first explain this. So the user R, Robert is actually following some category, but and here is how we match it. But now we also want to match this category to subcategories, because now we are interested both in C, the main category, and sub, which are subcategories. Now I'm going to do one trick that I'm not going to explain because it's some kind of or no, maybe wait a sec, maybe I can do it a bit differently. Okay, I'm now trying to match a product where a product actually belongs in a category C, or product belongs to subcategory. So I'm matching only the products that fulfill this relation. They either belong to a parent category or any of its children or descendants. So I'm now gonna return all the products, and no products. Just a sec. Let me check what went wrong. Let's try to see. Okay, the user is there. Let me check if there is a category and subcategories. Ah, okay, he's not following anything. Okay, we can try with Milos. Sorry about this. Hold on. Okay, and now for Milos, I can try to get the products. So yes, here are all the products that Milos might be interested in based on the category that he's following. He's following vehicles, but here you can see both bikes and cars. This is what we actually expected. Okay, and then the last, or not the last, almost the last recommendation. For example, when Tamara purchased a pair of shoes, they actually belong to a category shoes. So we can maybe recommend to her some nice boots or some nice sneakers. So let's do that. Let me check just a sec. So I will try to match Tamara first. Sorry. And then let's try to see which item she has already bought. So I'm checking for purchased products. And let's just return it for now to see if I'm on the right track. Okay, so Tamara purchased fancy Gucci shoes. And then I will try to match what she purchased. Let me just show you the diagram again. I'm trying to now match what she purchased to a category where it belongs. And then I'm gonna try to find the items in it. I'm not gonna include subcategories in it, but you already saw how this can be done. So I'm checking the product. It belongs to a category. Okay, let's return the category. Okay, now we have a category as well in the query. Yeah, I will try to match the product, another product which is similar to this one. I'll call it similar. Where similar belongs in this category C. This is what we selected. So basically now when I have a category, I can try to search for these two, and this is what this match clause is actually doing. Let's try to see if some similar products are returned. Yes, it's returned, but it has one problem. It also returned the item that Tamara already purchased. So let's just try to exclude this one. We can do it by ID. So I can say the similar.id is not equal to the original product that she purchased. And yeah, that's it. This is the recommendation for Tamara. So she got Gucci sneakers, Gucci boots, Gucci sandals, Nike sneakers, and Adidas sneakers based on the article fancy Gucci shoes that she bought. If I want to be a bit more specific, or let's say to introduce some kind of the most basic relevance, I would do something like this. So there is this function that would order stuff by text relevance. So I will try doing something like this. Sorry, distance, and then I'm checking the titles from the similar product to the original product that she bought. And I will, for example, limit just to 3 most similar products. And now when I execute this query, the 3 most similar based on the title will be these Gucci ones probably, and she will not get Adidas and Nike sneakers, if this works correctly. Yes. So yeah, this is some kind of another basic recommendation together with a similarity check. This is not usually the right approach to do it in the runtime. There are different ways to do it in the graph database, but I use this one just for a simplicity now. But performance-wise, it would not be. There are better options to perform this. I prepared one more recommendation, but I'm not sure. We should be finishing it. So I then advise you to just go to the GitHub and check it yourself. So you will find here the recommendation queries, and you will see the ones that I already executed plus the latest recommendation. The latest recommendation is you might be interested to follow this seller. For example, if Milos follows Dejan and Dejan follows Alex, we would like to check to recommend Alex to Milos. Maybe Milos wants to follow Alex. This is something that you can check yourself in the GitHub. So to wrap things up, the key takeaways. I would say that graphs are really cool. You should try playing with them and see it yourself. It's really easy to start working with them, but becoming advanced not that much. As I said, they're based on a mathematical graph theory. Everything in the graphs is basically nodes and relations. As we said, graphs are perfect choice for storing the data, where actually relations are the most important piece. For example, the real-time recommendation engine that we built. Whenever you want to query relations more than the data, the entities itself, this is the right data store for you. Graph database, again, are not supposed to fully replace the usage of relational database. I mean, yeah, you can store everything in the graph, but sometimes a grid is a better representation for your data than a graph, and probably very often. The last thing, again, I would advise you to check out, if you found this interesting, I would advise you to check out this code on GitHub, and you will see the presentation here, and also all the queries that we now have written together. So yeah, with this, I would close the presentation, and I would now leave time for Q&A.
Thank you, Ivan. Can you please paste the link in the chat box so maybe people can go and
yeah, good
check
idea.
the GitHub straight away?
Yes.
We had one question.
Just a sec.
Yes, please. We will send you the link of the presentation also, and all the links we even talked about in the email, follow-up email.
Okay, just a sec. I'm not really a Zoom user. No. Wait. Where can I paste this, Tamara?
You can paste the Zoom application. You go to Zoom app.
I do not see it. Okay, I will paste it meanwhile.
Yeah.
Can I answer the question?
Yeah, the question is Neo4j browser available in ONGDB?
Mm-hmm. So yeah, the Neo4j browser, yes, literally everything that is available in Neo4j is available also in the ONGDB. As I said, this is the database that we used, and this is basically a group of guys who are enthusiasts and who kind of forked what's free from Neo4j database and just added few plugins on top of it, so that it can be exactly the same as the paid version of Neo4j. We are using it for quite some time, and we're quite happy with it. But now I just realized that this does not answer your question. Your question was if Neo4j ONGDB supports the console. Yes, it supports everything that Neo4j supports. So basically, you can use this console, but even better, you have this nice. Now you don't see it because I'm just sharing my browser, but there is also a desktop app which is even nicer and works even smoother than the browser.
No, even we can see your desktop. We can see everything.
You can see the whole desktop. Okay, yeah. I thought you see just my browser. So yeah. There is this desktop app which looks similar to this, but has a bit more feature and works slightly better than the browser, even better.
And we have one more question from Slavisha. Slavisha is our colleague. He works with the Scriba. Hello. What is the most common file exchange format for graphs? We use GraphML, but is there something more standard?
File exchange format. What do you mean by that, Slavisha? Can you be a bit more specific?
We'll wait for Slavisha to answer. We have one more question. How do you connect to DB from code, REST API, or some kind of driver?
Yeah, good question. So I did not get into to these details. It depends on the database that you use, of course. But if you decide for Neo4j/ONGDB, you would have a protocol called Vault, and you can use this one, and it's recommended. You also have the REST API that you can use. But there are actually drivers for all popular programming languages, so you can just use their APIs and work with them directly.
Okay. Yeah. Peter answered.
Okay.
Slavisha, RDF is common.
Okay. Thanks. Okay. Thanks, Peter.
Igor, you can ask. You can also ask in a chat box or in a Q&A section. Okay, we answered that. Done. Yes, Slavisha said yes. Are you aware of some standards?
No, I get it. Now I get it. I get the question. Okay. But thanks, Peter, for answering this.
I don't have a question. I have a suggestion. Can Tamara purchase a Porsche instead of shoes? Please, next time.
It's a question for Tamara.
I say yes. Why not? Okay, we have one question. Have you set Neo4j in the cluster, and how many nodes you are able to handle? How many nodes you're able to handle? We gave up from Neo4j and used dgraph. Have you tried dgraph as well?
Mm-hmm. So yeah, we are using the cluster, the Neo4j cluster. We are actually now at 5 nodes, just because we would like to be able to have as much as 2 replicas failing at the same time. But traffic-wise, it would be, and it was perfectly fine when we had just 3 nodes. Resource-wise, I think at the moment we're running in the cloud, and each of the nodes has like 2 CPU cores plus I think 12 gigabytes of RAM. But don't take me for granted. I think it's like this at the moment. But yes, we're quite, as I said, we're quite happy with it. We have seen some problems with the cluster, but this is mostly because we were all new to this technology, so we didn't know how to hold it in the right way. After we changed configuration a little bit, these problems kind of solved themselves. It was mostly some kind of glitches and slowdowns rather than some bigger problems.
Peter says that you had a really good presentation.
Thank you, Peter.
Yes, and that's it. If nobody else has question, we will send you the links in a... Okay, we have one, sorry. Oh, have you tried dgraph?
No, I have not tried it.
Slavisha also says top quality presentation. Thank you, Slavisha. Okay, that's all for now. We'll send you, Igor sends link to dgraph.io.
Thanks, I'm gonna check this out.
Yes, thank you, Vladimir, for your comment. We'll send you in follow-up email all the links used here, and that's it. You can follow our social networks. So you can follow us on LinkedIn to get information about our next events and our next webinars. And we are preparing something special for you in the next few months. So be sure to follow everything. Thank you, everyone, again. Thank you, Ivan. Thank you for sharing. It was really nice.
Thank you.
And it was really clear for me also. I used to learn about databases a long time ago, but this was really interesting for me as well. Yeah, be safe, be healthy, be good, and see you next time.
Thank you, Tamara, and thank you everyone for joining. See you.
Thank you. Bye-bye.
Bye-bye.